Today's Quideo is on chapter 9 through 11, and we'll be discussing t-tests. The question states, a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. We are asked to determine if there is a significant difference in growth between the tomatoes with additives and the tomatoes without. So our parameter is the mean difference in growth of tomatoes with and without additives. Our hypothesis. So our HO or null hypothesis is mu of t minus mu of c equals 0. Our HA or alternative hypothesis is the mu of t is greater than the mu of c. The mu of t is the mean of seeds treated with additives, and the mu of c is the mean of control seeds. So our assumptions are, randomness is stated in the problem. The sample size is too small to assume an approximately normal distribution based on the central limit theorem. Our n is less than 30, so we will proceed with caution. We are using a matched pairs t-test, and the equation for this is t equals x bar minus mu over the standard deviation over the square root of n. To test the statistic, we plug in our values to our equation. So it would be t equals negative 2.015 minus 0 over 1.163 over square root 12. And this equals negative 6.0019. So to obtain our p-value, we use our t-table chart, and our p-value is less than 0.0005. We have a degree of freedom of 11 and an alpha of 0.05. Now we make our decision. Our p-value is less than our alpha level, so we reject the hope that the mean difference in growth of tomatoes with and without additives is 0. So our statement in context is, we reject the hope that the mean difference in growth of tomatoes with and without additives is 0 based on a p-value of less than 0.0005, which is less than our alpha level of 0.05.